So we've got y equals to kx plus 2. So this is a line. They say it will intersect the curve x squared plus y squared equals to 2. So they will intersect at two real and distinct points. Intersect at two real and distinct points. Okay, and distinct points. If this is not an A-maths question, if this is an E-maths question and they tell you that it intersects at two real and distinct points, what do you think they are trying to get you to do? Solve what? Substitution. Okay, what is this substitution for? What are you trying to solve? Substitution is a method for solving what kind of equations? Starts with S. Simultaneous equation. Look, I've got two equations over here. I've got equation number 1, equation number 2, right? So this is what it means. If I were to try and solve these two simultaneously, I will get two solutions. There will be two intersection points. You know what is the shape of this curve? Or this graph?
Straight line.
Straight line, because it is of the form y equals to mx plus c, right? What about this one?
Curve.
What kind of curve is it?
Parabola.
Really? Parabola? X squared plus y squared equals 2. Is it a parabola? Let's try and find out from Desmos. Let's see what this is. This is the shape of the graph. It is a circle. So now I have an intersection between a straight line and a circle. Looking back at this circle, do you agree that if I draw a straight line, the straight line may not pass through a circle? Possible? Possible, right? It is also possible that the line touches the circle at one point. Possible? It is also possible that the line cuts the circle at two different points. Possible? Any other possibilities?
No.
Okay. Any more?
It's inside the circle.
A line inside the circle?
But it goes forever.
Yeah, a line goes on forever and ever. So it either cuts 0 times, 1 time, or 2 times. Now if I try to solve this pair of simultaneous equation, using substitution that we have learned, sub equation 1 into equation number 2, what do you think we'll end up with? Let's try that. Sub, so this 1, this 2, sub 1 into 2. So we get x squared plus kx plus 2 and I squared equals to 2, right? So I can choose to expand this. Okay, x squared plus k squared x squared plus 4kx plus 4 minus 2 equals to 0. What do you think I'm trying to do over here? After I expand, what do you think I want to do next? Find discriminant. Before that, I need to make sure all my x terms are together, all my x squared terms are together, right? So let's do that. I've got 1 plus k squared x squared, this is my x squared term, plus 4kx plus 2 equals to 0. The reason I want to write it in this form is because I want to be able to see the discriminant from here. Okay? So discriminant is equals to, in this case, what will it be?
4 squared minus.
What about the k? I need a coefficient of x, right? So that will be 4k squared minus 4 times of
1 plus k squared.
And
2.
2. Okay, we can work this out. It gives us 16k squared minus 4 minus 4k. Oh wait, I made a mistake. This will be minus 8 minus 8k squared. Am I right?
Yes.
Okay, so we simplify this to become 8k squared minus 8. Am I right?
Yes.
What is the discriminant supposed to be equals to?
More than.
What did the question say?
More than 0.
it intersects at two real and distinct points. So what can you tell me about?
More than 0.
This must be greater than 0. Okay, this is an important key step. We say that the discriminant is greater than 0 because the circle intersects the line at two real and distinct points. Can? So from here, we know that, k square must therefore be greater than 1. And then how do I solve this? Wait, hang on. So let's not skip steps. K square minus 1 greater than 0. Okay, what do I do from here?
Move over minus 8 plus 1 plus 1.
Plus 1 plus 1. Okay, k square greater than 1, is it? Then what happens?
Square root.
Square root. Oh, okay. So k with a 1. So what is the sign over here?
Same.
Is it? Did I teach you this?
No.
What kind of inequality is this? What kind of inequality is this? There is a square term.
Quadratic.
Yeah, quadratic, right? If I were to flip just a few pages before that, I see quadratic inequalities. Isn't that the topic?
Yeah.
Okay. How do we solve quadratic inequalities?
More 3.
No. Huh? How do I solve quadratic inequalities? What formula? What formula? Factorize k square minus 1. Factorize to become
K square minus 1 square.
k plus 1 k minus 1, and this is greater than 0. Okay? And what do I do next? What do I do next?
K plus 1.
I need 2 points over here. What are they? Okay, negative 1 and 1. Then what do I do next? Curve. What kind of curve is it? Opening? Upwards. Okay. Like this. And then what happens? Where's the answer? Okay, so region number 1, region number 2, or region number 3? Which one? 1 and 3. So our answer is k less than negative 1 or k greater than 1. Is that what you're saying?
Yes.
Do you think this is the answer?
Yes.
Let's try. How do we try? Okay, I've got my graph circle over here, right? Let me draw in the next equation. Y equals to kx plus 2. Y equals to k. I don't have k. Okay. K. Y equals to k x plus 2. Look, this program is so good. It allows me to change the value of k. Do you see what's happening over here? Okay, so the blue line is my straight line. And do you agree that k changes the gradient of the straight line?
Yes.
Makes sense, right? Okay, if k is a positive number, I get a line sloping upwards like this, isn't it? Agree? If k is a negative number, it slopes the other way down, right? Okay, so depending on the value of k, my line will either not intersect the 0, or it may touch the 0, or it may intersect at 2 points. Yeah, they want to intersect at 2 points, right? So what are the values of k that allows me to intersect twice? Now, based on our answer, k is less than negative 1. Let's verify that. If k is less than negative 1, so this is negative 0.9. K is negative 0.9. Does it touch the graph? No. Okay. What about k equals to negative 1? What do we see over here?
A few times.
How many times does it touch the circle? Just once. Right? When k equals to negative 1, it touches the circle only one time. Now, in our solution, we say that k must be less than negative 1. So we are not going to accept negative 1 because I want 2 answers, right? So let's go back to the graph. Now, what happens when it goes less than negative 1? How many times does it cut? Twice. So as long as I keep going less than negative 1, it is going to cut twice. Okay? My range over here, I can reduce it somewhat. It can be negative 1 million if I like. If I have a graph of y equals to negative 1 million x plus 2, the graph slopes downwards, right? It is almost a vertical line, isn't it? It is very steep downwards. So we can see and we can extend that if k goes to negative 1 million, it will be a vertical line down, almost. And they will intersect at 2 points. Am I right? Okay, now let's go the other way. We said that also k is supposed to be greater than 1. Then I'll get 2 solutions, meaning 2 points of intersection. Can you make a guess? What happens if k equals to 1? It will not even touch, is it?
Touch once.
Touch once? Not touch? But we can be sure that it is not going to touch. It is not going to cut twice. Let's verify. So k equals to 1. When k equals to 1, it touches the circle. Okay, just one time only. And why do you think it touches only one time?
Because every less than means, if they say less than means got 2, right? That means at the point where you cannot get 2 is only 1.
Because the inequality sign don't have the...
Because the inequality sign don't have the equal to, right? But what happens when it is equal to 1? What can you tell me about the discriminant? What can you tell me about the discriminant if the discriminant equals to 0, right? What happens when discriminant equals to 0?
2 repeated roots.
2 repeated real roots, meaning what? How many intersection points do we see? 1 there. This is the one intersection point. Okay, now I want to go more than 1. And you see that, yeah, it's going to cut at 2 points. Okay, if I go to 1 million, for example, y equals to 1 million x plus 2, I will get almost a vertical line. And obviously, it will cut at 2 points, meaning 2 solutions. Get it? Okay, so any questions for this practice now 17, question 1? Any? No, then you are ready to do practice now 17, question 2 by yourself. Find the range of value of k for which the line will intersect at 2 real and distinct points. So, when they intersect at 2 real and distinct points, they are telling you that if you were to solve them simultaneously, you are supposed to get 2 answers. Solving simultaneously resulting in a quadratic equation giving you 2 answers means that b squared minus 4ac is greater than 0. Okay, so that's what we're going to do. Y equals to 11x minus x squared minus 3. That is my first equation. Thanks. Okay, equation number 1. And equation number 2 will be y equals to k plus 5 x minus 2. Okay, so we sub 1 into 2, 2 into 1 is the same, into 2. So we get 11x minus x squared minus 3 equals to k plus 5 x minus 2. I want to change it into ax squared plus bx plus c. So we have x squared plus k plus 5 minus 11x minus 2 plus 3 equals to 0. So x squared plus k minus 6 x plus 1 equals to 0. Do you all have this? Or did I make any careless mistakes? Okay, so discriminant around DISC equals to k minus 6 square minus 4 times of 1 and 1. What? What arrow? Where arrow? What, this one? Yeah, you can write that it is greater than 0 over here. I prefer to write it at the next step, the subsequent step. So I want to expand this first. K squared minus 12x minus 36, sorry, plus 36 minus 4. K squared minus 12x plus 32. This is supposed to be greater than 0. Okay? So now I want to factorize this. K, what is it supposed to be? Minus? Okay, greater than 0. Right? Then draw your axis, k axis. Parabola opening upwards. This being 4, this being 8. The region I want will be k less than 4 or k k more than 8. Is this the correct answer? Okay, good. I don't think you need me to go through work example 18. You can, but one thing to note, work example 18, I want you to look at the last line of the question. They say that y equals to kx plus 4 will be a tangent to the curve. Do you understand what tangents are?
Yes.
How many? Intersect sounds like it will cut, right? So we prefer to say touch. Okay, this is called touch at a tangent point. Do you know what they are trying to tell you about the discriminant? If they say it is a tangent?
Real repeated roots.
Yeah, 2 real repeated roots. Okay, so discriminant equals to 0. So please try practice now 18. Question 1. We will stop at 150. Question 1. Do you need help? No need. Who needs help for question 1?
Mr. Wong, can you explain the bottom part?
Only the bottom part.
Because for this kind of question, I thought, right, only got one answer. Then, answer.
Okay, class, watch the screen. I will not go into detail, but I will show you the approach. Line does not intersect curve. Oh. So the line does not intersect a curve. We write down y equals to kx minus 2. Y equals to x squared plus 3x plus 7. Equation 1, equation 2, sub 1 into 2. Then you will get ax squared plus bx plus c equals to 0. Discriminant less than 0. Okay? Tell me, what is your discriminant for part A, the first part? You want to tell me? K? K plus 3. And K minus 9. Less than 0. Do all of you have this? If you do, then we should have negative 3 and 9 over here. Therefore, K is between negative 3 to 9. That's the first part. What do you mean? Uh-huh. Yeah, K is less than 9. Yes. Why would K be more than 9? I want it to be less than 0. I want this portion. Okay? Question 2. Wait. Question 1. The part about tangent. Who needs help? Okay. So we will have the same y equals to kx minus 2 is a tangent. So we are going to have the same discriminant, just that this time it will be equal to 0 because it is a tangent. Therefore, k will be equals to negative 3 or 9. Okay? Yes? Both are accepted. No reason to reject any of them. Okay? Now for question 2. Line does not intersect the curve. So y equals to 5 minus 3x minus 2x squared. Equation number 1. Y equals to 3x plus k. Equation number 2. Sub 1 into 2. You get ax squared plus bx plus c equals to 0. And since they do not intersect, discriminant less than 0. This is if no intersection. Then for the second part of the question, discriminant equals to 0 if line is tangent to curve. Okay?
If exam don't know what is tangent, then like lose marks.
If you don't know what's tangent, then you cannot do then you don't know what's the discriminant. I mean, you cannot tell whether the discriminant is greater than 0, less than 0, or equal to 0, right?
Then if it's greater than 0, what would it have? Real and distinct.
It has two real and distinct roots, or it will tell you it has two different solutions. Can? Yes. Assume where? No, this is less than 0. This is if there is no intersection. You see question 2 has two parts. No intersection, then you do discriminant less than 0, then you solve the inequality. The next part of the question says that it is tangent, which means that discriminant is equal to 0, then you solve for, in this case, k. Yes? Question 2, k only have one value. Let me try. What do you have for the discriminant?
Negative 6.
Equals to negative 6?
Negative 6 squared minus 4. Negative 2 bracket 5 minus k 5 minus k.
What? Minus 5k? What?
Minus k. Minus k.
5 minus k, like this.
Yes.
Is this your discriminant?
Yes.
Okay, let's see what this gives us. 36 plus 40 minus 8k. So how many values of k do you see? 1. 1 ah. How to draw the graph? Wait. So this gives me 76 minus 8k. Okay? This will be equals to 0 if there is if the discriminant equals to 0. Right?
Yes.
Meaning k equals to what? 76 over 8. 9.5. Okay, so this is the answer for the value of k for which the graph is a tangent to the curve.
Mr. Wong, then, I'm very confused. This one more answer than the other previous question. Two answer.
You mean for question 2?
Question 2, the one answer, then question 1, the 2 answer.
Because question 1, right, where you have your discriminant, look at question 1's discriminant. It is quadratic. Question 1's discriminant is quadratic. So you will get two values if you solve a quadratic in this case. Whereas in question 2, the discriminant happens to be linear. So when you equate it to 0, you only get one answer.
So then how does the graph look like on the other side?
What graph are you talking about?
The first one.
Question 1?
Yes.
Okay, question 1. The graph for question 1, y equals to kx minus 2, y equals to kx minus 2. Okay, add a slider. Next one. Y equals to x squared plus 3x. Plus 7. Okay, so here we have two graphs. This is for question number 1. We see that, hey, are you all interested or not?
Yes.
Then you talk and talk, how are you going to listen? So as you can see, when k equals to 1, the graph does not intersect at all. The curve does not intersect the line does not intersect the curve. But when I change the value of k, we see that there is a possibility of one intersection, meaning one tangent, or two intersection points, right? Now the question wants the value of k for which it will be a tangent to the curve. That is at this point, k equals to negative 3. We see that it touches the curve at one point only. Okay, how many answers do we have? For question 1. What are they? Negative 3 as well as 9. So let us go back to this. We will extend it to 9. So over here, can you see it? It touches at one point only, which is found here. Over there. Tangent again. Okay? That is for question number 1. Do you want to see the curve for question number 2?
Yes.
Okay. Y equals to 3x plus k. Y equals to 3x plus k. And the curve will be 5 minus 3x minus 2x. Okay. 5 minus 3x minus 2x squared. Okay, parabola and straight line. As my k changes, my line slides to the left, to the right. See how the straight line changes as I move my slider, as I change the value of k? So in this way, if I want doesn't intersect, then my straight line has to be on the left hand side, corresponding to values greater than 9 point something, 9.5. Okay, so you see when k is greater than 9.5, it starts to go further and further away from the curve already. That's why there is no intersection. And if you want a tangent, it happens only at one point, which corresponds to k equals to 9.5. Okay? And are you able to do this for yourself online? I'm sure you can. I'll show you how to do it already. It's very easy. You just go online, type in the equation and explore yourself. Can? Okay.